Hello everyone, myself Shinde working as Assistant Professor at Department of Physics, KTGM College, Nasik. Today we have going to discuss MSc second year semester 3rd paper number 4, that is the course of Energy Studies first. Today's lecture we have discussed the nature and measurement of solar radiation. In chapter 2nd, solar radiation and its measurement. In today's lecture, I have covered the nature of solar radiation in point beam, diffuse, and global radiation. And another one point I have also discussed the solar radiation measurement equipments. That is the pyrometer, perihelimeter, and sunshine recorder. First one, we have discussed the nature of solar radiation. Following are the types of solar radiation based on their nature. First one, the diffuse radiation. Diffuse radiation is defined the solar radiation scattered by aerosols and dust molecules. It does not have a unique direction. The diffuse radiation, that's how also defined that the solar radiation scattered by aerosols and dust molecules, it does not have unique direction. It does not have unique direction. And the another one type is direct radiation. That portion of incident solar radiation which comes directly from the solar disk without reflection from the other object is called direct radiation. In here, portion of incident of solar radiation which comes directly from the solar disk without reflection from the other object. It's called as direct radiation. And the third type is extraterrestrial radiation. The solar radiation incident on outside of the Earth's atmosphere is called extraterrestrial radiation. I have also discussed another one type, solar radiation measurement equipment. Experimental determination of the energy transferred to a surface by solar radiation require instruments which will measure the heating effect of direct solar radiation and diffuse radiation. In here, the experimental determination of energy transfer by the solar radiation which require the instruments. That's how the heating effect of direct solar radiation and diffuse radiation. In measurements are also made of beam radiation, which responds solar radiation received from very small portion of the circumsolar sky. A total radiation type of instrument may be used for measuring diffuse radiation along by sharing the sensing element from the sun's direct ray. A total radiation type which measuring diffuse radiation along by sharing the sensing element by the direct radiation. In measurement, they have classified that. First one, pyroheliometer. A pyroheliometer is an instrument for measuring the intensity of direct solar radiation at a normal incident heat. These instruments are used to measuring the intensity of direct solar radiation by the normal incident. Can either be a primary standard instrument or a secondary instrument scale by reference to a primary instrument. They have two instruments, the primary standard instrument or secondary instrument by the scale referred to a primary instrument. The latter have sometimes been called actinometer. Pyroheliometer in a small telescope-like device mounted on a drive mechanism, that is to follow the sun through the day. Second one, pyranometer. A pyranometer is an instrument for the measurement of the solar radiation received from the whole hemisphere It is suitable for the measurement of global or sky radiation, usually on a horizontal surface. Pyranometer is an instrument for the measurement of the solar radiation received from the whole hemisphere. It is suitable for the measurement of global or sky radiation, usually on a horizontal surface. It shears from the beam radiation. By a shearing, it measures diffuse radiation. It measures the diffuse radiation. The pyranometer is sensitive to radiation from an entire hemisphere and usually mounted in that hemisphere in a skyhook. The energy measurement or energy measured by pyroheliometer is that energy which is available to a typical focusing solar energy collector system. The focusing, that is solar energy. The energy measurement by the pyroheliometer in that energy which is available to typical focusing solar energy collector system, and the pyranometer is sensitive to radiation from an entire hemisphere and usually mounted in the hemisphere in skyhook. That's the difference of pyranometer or pyroheliometer that have the measuring factors or measuring the solar radiation or solar energy by the in solar radiation measuring factors or system. The energy measured by the pyranometer is that energy which is available to a flat plate collector system. The energy measurement by the pyranometer is that energy which is available to flat plate collector. The horizontally mounted pyranometer measures the total amount of energy or feeling on surface of the earth or on a horizontal surface. That the mounted pyranometer, the measure total amount of energy feeling on the surface of the earth or on a horizontal surface. And the third one type is piezometer. A piezometer is an instrument for the measurement of terrestrial radiation only. That the terrestrial radiation is measured by in this instrument. Pyradiometer. A pyradiometer is an instrument for the measurement of both solar and terrestrial radiation. That is for the net atmospheric radiation on a horizontal upward focusing black surface at the ambient air temperature. The net atmospheric radiation by the horizontal upward focusing black surface at the ambient air temperature. Another one, the international scale by pyroheliometer. The two standard reference pyroheliometers have been in use for many years, the Abbott or Smithsonian instrument and the Armstrong instrument. That's how the two instruments are in here refers that. The scale defined by these instruments did not agree, and in 1956 a new 3% national pyroheliometer scale in 1956 was established which applied correction to previously obtained measurement for each of these minus 2.05 to the Smithsonian scale. That's in here the difference we have in here discussed. That is the error by minus 2.05 to the Smithsonian scale, 1.6% to the Armstrong scale. All instruments manufactured by the calibrate since 1956 to use new scale data. International Pyranometer Standard. Intercomparison of standard pyranometer was accomplished through the leadership of International Solar Energy Society in 1971. The result of this comparison up to 21 working standard pyrometers from meteorological instruments throughout the world are detailed by the PHOP234-K. The major issue to be resolved was selection of the standard that should be adopted and again which the pyrometer should be compared. This pyrometer should be compared that. And the another one, pyroheliometers. Most pyroheliometers used for round line measurements operate on a thermopile effect and are small to pyrometer in this respect. They differ in that mechanically they must follow the sun to measure only direct sunlight and avoid the diffuse components that have to measure that only the direct sunlight and to avoid a diffuse component, not a measure that diffuse radiation or terrestrial radiation that have only the direct sunlight. We have measured that in this instrument. In practice, direct solar radiation is measured by catching by the instrument to an electrically driven equatorial mount for tracking the sun. The diffuse component is avoided by the installing a collimator tube over the sensor with a circular cone angle of about 5 degrees. It may be noted here that a solar intensity thus measured includes both the beam and forward scale radiation which come from circumsolar sky. That's come from circumsolar sky and is collected by the pyroheliometers within its acceptable angle. That the inaccuracy in measurement due to in this scattered radiation is difficult to estimate and increases in weather conditions. It increases by the weather condition. Inaccuracy by measurement of scattered radiation is difficult to estimate. Problems with pyroheliometers measurements are several fold. The appear angle, the motor contribution and the impression in the tracking mechanism. A motor contribution and impression in the tracking mechanism. That the first two problems are almost to estimate because of the inability to define the solar disk precisely and the fine dimension of the instrument components. The practical matter of precision tracking and sensor orientation are similar grade. That's similar that the precision tracking and the solar orientation. The use of correction factor is not only involved but somewhat unreliable. The direct solar components on a horizontal face may also be often use a shading ring tie-in cone by subtracting the shear come from the unshared or global reading. In figure showing that the receiving element that the diffuse components of solar radiation by and measure that global readings that have a use in this instrument or in this method we have showing that in figure. The current practice in solar radiometry relies primarily on thermoelectric transducers. However, relatively low-come photovoltaic transducers are becoming more popular that the thermoelectric transducers or photovoltaic transducers. In that the more popular that in working in that solar radiometry. The current practice that the solar radiometry in these two transducers are become more popular that. To more the direct solar radiation, the receiving surfaces must be normal to direct solar rays. That is a line joining the solar and receivers. The line in that joining that the sun and receivers that the direct solar rays normal to the direct solar radiation to receive that the direct solar surfaces or normal direct solar radiation. The 3 pyroheliometers have been in widespread use to measure normal incident beam radiation. That's how these 3 are, and first one an Armstrong pyroheliometer, second one the Abbott silver disc pyroheliometer, and last one Ripley pyroheliometer. In 3 types of pyroheliometers. Studied with detail Armstrong pyroheliometer. The thermocouple on back strip connected in opposition through a sensitive galvanometer or other full detector are used to test for the equality of temperature. The thermocouple on a back strip connected in opposition through the sensitive galvanometer. The energy gauge of direct radiation is calculated by means the formula capital H suffix Dn is equal to Ki square. That's how where HDN is a direct radiation incident on an area normal to the sun's ray. I is heating current in amperes and K is a dimension and instrument constant. That is equal to R upon W alpha, where the R is the resistance per unit length of a absorbing strip. W is a mean width of absorbing strip in centimeter, and the alpha is the absorbing coefficient of absorbing strip. That's how we discuss the formula by. The second type of pyroheliometer is Abbott silver disc pyroheliometer. It consists essentially of a blackened silver disc positioned at the lower end of a tube with to limit the hole aperture to 5.7. A mercury in glass thermometer is used to measure the temperature of the disc. A shooter made of 3 polished metal leaves is provided at the upper end of the tube to allow solar radiation to fall on the disc at regular interval, and the corresponding changes in temperature of the disc are measured. The thermometer pin is bent through the 90 degree so that lies along the tube to minimize its exposure to the sun. The instrument much of course be calibrated against a primary standard, but their stability of the found that the very good, and they are widely used for calibrating pyranometers. And last one, Eplev pyranoheliometers. The sensitive element in an Eplev pyranoheliometer is a temperature compensated 15 generation bismuth silver thermopile mounted at the base of a brass tube, limiting diaphragms of which sustain an angle of 5.7 mm. A thermopile is basically a series arrangement of thermocouples used to develop a much greater voltage than is possible use only one. That's how this is arrangement of thermocouples to develop or use to develop the greater voltage than is possible use only one that. The tube is filled with dry air and is sealed with crystal quartz window which is removable of the filter is Phillips standard that. It is a stable instrument and can be used and NUB standard. This instrument has been found that acceptance within the USA and many parts of world. In this lecture, I have covered the nature of solar radiation and solar radiation measurement equipments. Thank you.